all about the different types of software, let's get into the different types of hardware. So whenever you're going to purchase a new computer or build a new computer, you need to know about the different components you're going to be purchasing. You need to know what are their specifications, why do you need what you need, like how much is enough, how much is too much, and really that boils down to making sure you have a good knowledge of what it all means. So then when you can make a good decision when you're at the store and you're looking and comparing the different components. So we're going to start looking at the two different types of hardware. And for us, there's going to be internal and external components. And this is going to give us a good idea of every little piece. Now we're not going to look at everything because we can't, there's just not enough time, and really not every little piece is as important as the ones we're going to be looking at. So there's two types, the internal components, so the components inside the actual computer itself, and the external components. These are usually your peripherals, your keyboards, your mice, your screens, things like that that are outside of the box itself. So this lesson is going to focus on the internal components. But first of all, we need to look at what all the hardware really does. So a computer really only does 4 basic operations. Input, so it gets data from the user or a network and brings it into the computer, so data coming into the computer. Processing, so the processing actually takes that data that was brought in and manipulates it in some way. So if we're talking about, like, maybe you took a picture with a webcam and then you brought it in and then you start manipulating that video or that image, and that's the processing of it. All right? Or maybe you're talking about a calculator on your computer. Your input being the numbers that you type in, the processing doing the mathematical operation that you choose. Storage. After you've processed that information, we need to store that data. You need to store the result for future purposes. So maybe you're just going to display it, maybe you're going to use it in future calculations. Who knows what you're going to be using it for. But every time we process, we need to store the results. Oftentimes, when we're talking about different applications of computer or different applications, processing and storage is often grouped into one little piece, and this is just because every time you process, you're going to store, so there's no real point in breaking them up. So a lot of times it's just input processing / storage as opposed to input processing storage. And then finally, output. This is where we give feedback back to the user. So this is information coming from the computer out to the user. And this can come in a variety of different formats, which we're going to talk about more in the external hardware section of the lessons. So altogether, these spell an acronym of IPSO, IPSO, but if we group together that processing storage, it's just going to be IPO. It all depends on how we want to look at it. So all software will follow these 4 operations in that order. You're going to give in some data, it's going to change and manipulate that data in some way, it's going to store the result, and then it's going to give you feedback. That's what programs do. Now, more complicated programs will do this millions, maybe even billions of times in a single program. Simple programs may only do it once. It depends on what you're building. So the data. It's important to understand how the computer actually interprets information. Now remember, a computer is just a machine. Machines only understand certain things. They certainly don't understand letters, numbers, English, or anything like that. So when humans think of data, we think of information that everything has meaning behind it. So for a computer, it's just software that gives the data meaning. So depending on what software is running, that data could mean something different. So for example, if you're using Microsoft Word and you hit the W key, then that's going to show a W on the screen. But if you're playing Call of Duty or something like that and you hit the W key, your character moves forward. It has a completely different meaning based on the software that's currently running. So to the computer, when it sees data, it doesn't see the same thing we see. It doesn't see a W. It sees everything in a sequence of ones and zeros. And really it doesn't even see ones and zeros. What it actually sees is high voltage and low voltage. That's all a computer can really understand is electricity. So a high voltage is interpreted as a 1 to us, but it means high voltage to the computer, and it can also interpret low voltage. We translate that to a 0, so ones and zeros. Together, when these ones and zeros are grouped, they can actually have meaning behind them. So a sequence of ones and a sequence of zeros, and this setup of ones and zeros, this system of ones and zeros, we often call binary language, so binary data. Binary meaning 2 choices. So a single 1 or a single 0 is called a bit. And we group these things together to make larger measurements or quantities of data. And and we'll get into that in a little bit more. But the smallest unit of measure of data possible is a bit, and that's a 1 or a 0. So looking at the internal components of a computer, these are the pieces that we're going to look at, and we're going to try and compare them to the human body, because a lot of times the human body is a great representation of what a computer really is. And sometimes I think that that's what computer scientists were basing everything on in the very beginning, because it is so analogous of the human body. So we're going to talk about the motherboard, the bus, central processing unit, hard disk drive, random access memory, network interface card, the graphics card, and the sound card. Now this is just going to be a top high-level look at everything, because this is, after all, a software course, and we're just touching on it so you have a basic understanding of what all these different components are. So first of all, the motherboard, otherwise known as the MOBO. And this is a processing device. It manipulates data, it moves it around and everything like that. So what is it? The motherboard is what we call the central nervous system, or the CNS, sometimes the spine of the computer. All components of the computer plug into the motherboard, either directly, right, attached right to the board itself, or indirectly via some kind of cable of some kind. So for example, a hard drive is connected using a cable, whereas a graphics card is plugged in directly into the board itself. So the MOBO is by far the most important component of any computing device, because it's what brings everything together. It allows communication between all the different devices. The bus. Think of this like a highway, and it's how information travels through the computer. It goes from A to B on the bus. So much like in our world, the bus is a device used to transport things around. In our world, these things are people. In the computers, it's just electrical signals, those high voltages and low voltages, or ones and zeros. In the human body, it'd be like our veins that the blood is passing around all day, or the nerves, I guess you could say, where the electrical signals are flowing through the nerves to the different parts of the body. So any data signal passed between any two components is going to travel along the bus, right? So, well, we'll just leave it there. It does just manages and transports the data from A to B. Now, the central processing unit, often called the brain of the computer, is what does all the math. So it also allows certain permissions between different devices and whatnot. Yes, you can talk to this, or no, you can't talk to that. But mostly it just does basic math. So it's like a supervisor and a calculator all in one. So it reads in binary data, ones and zeros, as input, as well as operations, plus, minus, multiply, divide, modulus, all sorts of different things. And it's in charge of governing all the components that get access to one another, as well as doing the math. So at the most basic level, when we're talking about math, this is really all the CPU does is add. All other forms of math can be converted into addition for the most part. So for example, 5 plus 3 is 8. But you can also do 5 plus minus 3. That's the same thing as saying 5 minus 3. It still works out. You want multiplication, 5 times 3, that's really just 5 plus 5 plus 5. Same thing, even division can be broken down into addition to some degree. So that's all the CPU really does, is adding and governing. The hard disk drive. So I should go back very quickly. The CPU is, of course, a processing device. And then the hard disk drive, this is a permanent storage device. It's meant to maintain data over a long period of time. All right, so this is where when you save your file, say for example a Word document, it goes to the hard drive, right? And it'll stay there forever until the hard drive either dies or you manually delete the file. So the hard disk drive, it's called this because the data is actually stored on these things called platters. They look like little silver discs, and they're magnetic in nature. So all the data is stored magnetically. So instead of high voltage, low voltage, is more like positive and negative. They're magnets, right? And it stores the data sequentially. And what that means is that when one file saves its data, it's just going to have a sequence of ones and zeros, one after the other. And when we want to get from point A to point B on the disk, what happens is the disk starts spinning. And as it spins, the data is actually stored in a sequence in a circle around that disk. And there's an armature that will move around side to side on the disk and wait for the data that's spinning around to reach the armature. It'll read it as the disk spins by, one bit at a time, 1101011010 as it spins. But what this means is because the data has moving parts and it's got to wait for the disk to come around and the data is stored sequentially, what this basically means is it can actually be quite slow because it has to wait for all that data to spin by. It's got to wait for that opportunity. The way I like to think about it is if you have a favorite movie and it's stored on an old school VHS tape and you want to get to your favorite part, it's like holding down the fast forward button to wait until you get to that favorite part. It might take you a couple minutes. You're going to hold that fast forward button until you get there. So because you're waiting for the whole thing to pass by, we got to wait for all the information to pass by before we get to the one we want. So it is a very mechanical process, and it is actually quite slow. The short form for a hard disk drive is an HDD. We don't use HD because that has different meaning, whether that's high definition or whatever we're talking about at the time. So the data, as I mentioned before, is stored magnetically. So what this means is no power is required to maintain the data. So if we shut down our computer, the data is still going to be there when we turn our computer on tomorrow. So because of this property, we say that the data is non-volatile. Volatile means unstable. So when something is non-volatile, it means that it's stable. So even if the power goes out, we're still going to have our data. So this is our long-term permanent storage, which leads us into our short-term storage, temporary storage. So this is like your short-term memory in your brain, whereas the hard disk drive is the long-term memory. So random access memory, or RAM, which is a very big misnomer, it is meant for short-term memory. It's meant to store data that is currently in use by the computer. So what that means is, let's say for example you open up Word. The computer will go to the hard drive, grab all the files that are important to Word to make it run, and then copy them into the RAM. And the reason why it does this is because RAM is actually very, very fast, relatively speaking, to the hard drive. We'll get into why that is in just a second. But so the RAM itself, it stores this data while it's in use. When we're done using Word, it removes it from the RAM, and that's it. It's gone. It doesn't need to store it back in the hard drive because it already exists in the hard drive. Okay. Same thing when you open a file. When you open a file, let's say a Word document, it will read it from the hard disk drive and copy it into the RAM. We'll manipulate it in the RAM, and it doesn't go back to the hard disk drive until we hit the save button. So if we lose power, or I'm sure you've all dealt with this before, if the computer just shuts down for some reason and we didn't get a chance to hit the save button, we've lost all that work. It's gone. So this is actually a property of RAM. So RAM does not store its data magnetically. It actually stores it electronically, which means it requires power, at least a tiny trickle of power running through it to maintain its data. So if we shut down our computer or the power goes out, it no longer has that charge to maintain the data. So it loses it. So for this reason, we say that RAM is volatile. It's unstable, which means when power goes out, we lose that data. So the data is stored electronically, and in order to access the data, it's not sequential, right? It's all stored in very select compartments, memory addresses, and everything just kind of like when we go to access data, it uses something like a table of contents called a lookup table. And what happens is when we want to open a certain location, it checks this table of contents and jumps directly to that point in memory, reads what it needs, and gives it back to us. Now that is fast. That, in fact, we say that runs in constant time. It's instantaneous. So that's extremely useful. And we don't have to wait. There's no sequential access. There's no moving parts. It's all electricity. Okay? So RAM is super duper fast. But we got to be very careful. It's called random access memory, but there really is nothing random about it. It's not like it randomly jumps to a location in the memory and hopes for the best. That's not the way it works. Random is kind of a misnomer in this case. In reality, it should be called direct access memory, if you really want to. So it jumps to the direct location. But I don't think the acronym DAM is as appealing as RAM. So yeah. Anyways, so we have our random access memory, which jumps directly to the destination. So if we want to go back to our movie analogy, instead of fast forwarding to our favorite part, now it's more like choosing the scene selection and just jumping directly to our favorite part. We don't have to wait for anything, it just goes. So RAM is volatile, stores its data electronically. It's short-term memory, and it's used for data that's currently in use at the moment. So the network interface card, or the NIC card. This is one of the few devices is both an input and an output device, because it takes data from the outside world and brings it into the computer, but it also does the opposite. It takes data from the computer, it sends it out to the outside world. So it's a device its sole purpose is to interpret data for a network connection. So going both in and out. So it interprets those binary ones and zeros and sends it to the CPU, which then sends it off to the appropriately running software. So if you're playing Call of Duty and it needs to update where all your opponents are, it gets that data from the network, sends it to the currently running software, which is Call of Duty, and then the software interprets that and handles it the best way it needs to. So any NIC card will typically connect to another device that sends or receives the data, usually like a modem or something along those lines. And that's the data that actually that's the device that actually connects to the network. The NIC card doesn't actually connect to the network. It's more the interpretation device that deals with the incoming and outgoing data. And then we have the graphics card. This is another processing device. It's just like a CPU. Sometimes it's actually called the graphical processing unit, or GPU. Now the graphics card, its sole purpose is to do the exact same thing that a CPU does, math. But it only deals with image data, videos and still images and whatnot. So it's used to create a visual representation of data. So when it sees ones and zeros, it's trying to interpret it as an image of some kind. It's trying to interpret it as, how should I color each pixel on the screen? So this one converts binary image data into actual images in the form of colored pixels. And then it sends that data off to our monitor, and the monitor then displays it appropriately. So this can oftentimes be the most unneeded and expensive device in a computer, as most CPUs can actually handle the work of graphics when you're talking about normal software. When you're talking about intensive games, you're going to need a GPU. You're going to need a graphics card. Otherwise it's going to chug and you're not going to be able to handle all the intense action going on the screen. And finally, we have the sound card. It's the same thing as a graphics card, except for audio. So it does the exact same thing. So it's used to create an audio representation of data. So when it sees ones and zeros, it doesn't convert it to an image. It converts it to sound, frequencies, pitches, all these kinds of things. So it converts sound. And the sound card, again, can go both directions. So it can take the image or take the sound data from a microphone, but it can also deal with sound data that's going out to the speakers. So it can handle both interactions. So this is another device that can be typically left out, because again the CPU can handle most of this stuff. Unless you really need that, surround sound or whatnot, your sound card can oftentimes just be left out. So that's it for the internal components. In the next video we're going to talk about all the different measurements and quantities to deal with some of these internal components.